Good morning students. In the previous video we have completed the electrolytic cell and the process which occurs in electrolytic cell is electrolysis, and two examples we have for that is electrolysis of molten NaCl and aqueous NaCl. Also the quantitative aspects of the electrolysis, that part we covered, and we have solved the numericals which are based on that. Now the second type of electrochemical cell is called as a galvanic cell or voltaic cell. What is galvanic cell or voltaic cell? It is a device which is used to convert chemical energy into electrical energy. A device which is used to convert chemical energy to electrical energy is called as a galvanic cell or voltaic cell. In this, electricity is generated because of spontaneous chemical reaction. And in galvanic cell, anode is a negative electrode where oxidation half reaction took place, while the cathode is a positive electrode where reduction half reaction occurs. So how to construct the galvanic cell, that part we will discuss. So construction of the galvanic cell or voltaic cell. This galvanic cell, it consists of a two container containing a metal strip is immersed. Metal strip is immersed into the solution of its own ion. Suppose this is metal strip M. It is in its solution of ion. Its own ion will be Mn+. Having concentration, specific concentration. Suppose concentration is 1 molar. If you have to specify the concept, let us consider the metal is zinc. Zinc is placed into its aqueous solution of its own ion or solution of its own ion Zn++, having specific concentration, suppose 1 molar. So this is one electrode. Now second metal electrode, it is immersed again into its ion Mn+, having concentration, suppose 1 molar. So these are the two half cells. Two half cells consist of the metal strips immersed into the solution of their own ions with known concentration. These two metal electrodes or metal rods are connected by a metallic wire to a voltmeter. The electrode, negative electrode called as an anode. Anode is the negative electrode where oxidation half reaction takes place. Oxidation half reaction occurs, while cathode is a positive electrode. Cathode is positive where reduction half reaction took place. So this is the construction of a galvanic cell or voltaic cell. May I repeat again how we are constructing? Take a two half cells or two containers, insert the metal strips in with their own ions with known concentration, and that will form a half cells. These two electrode connected negative electrode, that is anode, is called as the anode where oxidation half reaction occurs, while the positive electrode is called as a cathode where reduction half reaction took place. These two electrodes are connected by a metallic wire to a voltmeter. So this is the construction of galvanic cell. Suppose when we are considering a metal rod zinc and in Zn++ solution, then zinc rod undergoes oxidation reaction, while the cathode, these electrons will transfer from anode and it will be accepted by the copper++ ion from copper sulfate solution or Cu++ solution. So second rod will be, suppose this is copper, in its ion solution will be Cu++ ion. So here zinc will undergo oxidation and here copper is undergoing reduction. So if you are considering the two metal strips as the zinc and copper in their respective ions, then that cell is called as a Daniell cell. That Daniell cell construction we have in 11th standard state board syllabus. So how we have to construct the galvanic cell or voltaic cell. Now the concept related to galvanic or voltaic cell. Now some small notations are there. We are able to note small short notations are there for constructing the galvanic cell or voltaic cell. What are that short notation? That I will explain. Now while writing the galvanic cell in short notation, several rules are there. What is the first rule? The electrode, metal electrodes we have to write to extreme end of the cell. So metal strips or metal electrodes we have to write to extreme end. Suppose we will consider the same example. Here zinc is the one electrode and here copper electrode. So what is our first rule? We have to write the electrode to extreme end, zinc and copper. But while writing the electrode at the extreme end, again there is a one condition, that is second one. The electrode where oxidation reaction took place, oxidation half reaction occurs, that electrode we have to write to extreme left hand side. So if you observe, this is the zinc where oxidation half reaction took place. So while writing galvanic cell, the electrode where oxidation half reaction occurs, that we have to write to extreme left side. While the electrode where the reduction half reaction occurs, that we have to write to extreme right hand side. So here zinc we will write to left side and copper we will write to right hand side. This is the first rule. What is second rule? If any gas electrode is there or any insoluble electrodes are there, here it is metal electrodes are there, copper and zinc. But in case of if any inert electrode or gaseous electrodes are there, then they are placed interior to this metal electrode. For example, again, suppose here zinc is one electrode and another electrode is suppose gas electrode like hydrogen gas electrode H2. Now when we are using H2 as a half cell, then we have to immerse one inert metal called as a platinum. So platinum we have to insert for electrical contact. A single vertical line is drawn. So this is a gas electrode, platinum in contact with hydrogen gas. As it is a gas, we have to mention some pressure also. Suppose 1 atmospheric pressure. Hydrogen gas is having pressure 1 atmospheric pressure. So gas electrode we have to write to interior side of the metals or metal electrodes. So here zinc and that side hydrogen electrode is there. So platinum is for electrical contact. It is an inert metal. In contact with single vertical line shows the contact between metal and its electrolyte solution. So platinum in contact with hydrogen gas at 1 atmospheric pressure. Here, if any aqueous solutions are there, then we have to write that aqueous solutions of their own ions in the middle of the cell. Suppose zinc is there. Zinc is in contact with which solution? Zn++ ion. So we will write the aqueous solution of that electrolytes. We have to write to the interior side of the metal. So Zn in contact with Zn++ aqueous, having suppose concentration is given here, suppose 1 molar. That we have to write. What is second electrode? Suppose here example is there. Copper is in contact with Cu++. Copper we have to write extreme right hand side. Then it is in contact with Cu++ ions in aqueous medium, having concentration 1 molar. Okay, now if you consider the second example, one electrode is zinc and second one is gas electrode. No doubt after the platinum hydrogen gas at 1 atmospheric pressure we have mentioned. Then this hydrogen gas is in contact with H+ ion aqueous, having concentrations of C1. Or we will write 1 molar concentration, particular concentration of we will mention with concentration 1. So this is the representation of gas half cell and this one is for the metal half cells. Now this is one electrode, this is another electrode. Here also zinc in contact with Zn++, copper in contact with Cu++. These two electrodes or these two half cells are connected by a salt bridge. So if you observe this diagram, here these two half cells are there. I will show here also. These two half cells are connected by a salt bridge. What is a salt bridge? If you observe, it is an inverted U shape. See this one, I'll write over here. This is a salt bridge. What is salt bridge? May I repeat again? What is the function of salt bridge? It connects these two half cells. So what is a salt bridge? Inverted U-shaped glass tube. See here. Inverted U-shaped glass tube whose ends are closed by using a glass pulley. This inverted U-shaped glass tube, it is filled with, see, it is filled with a saturated solution of KCl, potassium chloride, salt, KCl salt, or ammonium nitrate. It is filled with KCl salts like KCl or ammonium nitrate in 5% agar solution. 5% agar solution. What is agar solution? It is a gel-like solution. It is obtained from seaweeds or it is obtained from red algae. So, what is the salt bridge? Inverted U-shaped glass tube whose ends are closed with glass wool. This salt bridge is filled with the saturated solution of salts like KCl or ammonium nitrate in 5% agar solution. When it is not in use, when it is not inserted into half cell, then it will be immersed. It is kept, or immersed better, it is kept in a distilled water. When it is not in use, it is kept in distilled water. So this is the salt bridge. Now see again representation of salt bridge. This salt bridge is indicated in convention by the double vertical line. So what is double vertical line? It indicates the indirect contact between the two half cells by a salt bridge. So this is the construction short notation for the galvanic cell. Now again come to the salt bridge concept. What is the function of salt bridge? If you observe, first function is it connects the two half cells of the galvanic cell. Second one, it maintains the electrical neutrality by exchange of ions. That is the second one. What is the third one? Two are already I explained. It connects the two half cell. It provides the electrical contact between two solutions, and also it prevents the mixing of these two solutions. It provides the electrical contact between two solutions. It connects the two half cells. It maintains the electrical neutrality. These are the functions of the salt bridge. Generally, there is a separate question is also there. What is a salt bridge? Describe the construction and working of the salt bridge. May I repeat the answer for this question? Salt bridge is inverted U-shaped glass tube containing saturated solution of KCl or ammonium nitrate in 5% agar solution, or salt solution of KCl and ammonium nitrate in 5% agar solution. Ends of the salt bridge are closed with a glass wool. Function of salt bridge: it connects the two half cells in galvanic cell. It maintains the electrical neutrality, and it prevents the mixing of two solutions. So these are the functions of the salt bridge. And what points we have started? What are the short notation for representing the galvanic cell? May I repeat again? The electrode, metal electrode, we have to write to extreme end of the cell. Then, if gas electrode is there, then the inert metal like platinum or any gas electrode, it is placed, like platinum is placed interior to the metal electrode. Then, after this metal rods or metal electrodes, the electrolyte solution of known concentration is placed in the middle of the cell. A single vertical line indicates the phase separation, or it can shows the direct contact between metal and its electrolyte solution of its own ion. Then double vertical line is drawn in between the two half cells. This double vertical line in the galvanic cell, it represents the indirect contact between the two half cells, or it indicates the contact between two half cells by a salt bridge. So this is the short notation for the galvanic cell. Now continue with this one only. We have to write the cell reaction. How to write the cell reaction for the galvanic cell? Now for writing cell reaction, we know that reaction which occurs at anode is oxidation half reaction, while the reaction which occurs at cathode is the reduction half reaction. Oxidation is the loss of electron and reduction is the gain of electron. If you observe this galvanic cell, zinc is in contact with Zn++. It acts as a suppose anode. So where oxidation half reaction took place with loss of electron. While at cathode, reduction half reaction took place where copper ++ ion gains the electron and it is converted to metal copper. So these cell reaction, oxidation half reaction and reduction half reaction. How to write the oxidation half reaction and reduction half reaction in galvanic cell? Suppose this galvanic cell is given in short notation. So what is electrode to the left side is oxidation reaction, undergoes oxidation half reaction, or it acts as an anode. So on the left side the electrode is zinc. So reaction at anode. Reaction at anode. Which reaction is at anode? Oxidation half reaction. CO. Zn. Zn is converted to what? Zn plus plus aqueous with loss of 2 electrons. So this is oxidation half reaction. Now which undergoes reduction? This one, Cu plus plus ion gains the 2 electron and it is converted to Cu. That is the reduction reaction. So reaction at cathode. Which reaction is at cathode? Reduction. Reduction half reaction. So which one is the reduction half reaction? Cu plus plus ion gains the 2 electron and it is converted to Cu. So this is our reduction reaction. And what about redox reaction? Addition of oxidation and reduction is called as the redox reaction. If we add these two reactions, we will get the overall reaction called as the redox reaction. Overall reaction. So what is the overall reaction? 2 electron gets cancelled. So what is remain? Zn. Zn plus Cu plus plus gives, what it gives? Zn plus 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 Cu. And E0 cell, electromotive force, E0, standard EMF of this cell, E0 cell is found to be plus 1.1 volt for this one, for this galvanic cell. This much potential, electrode potential or cell potential, standard cell potential will be developed on the galvanic cell. So this is the method of writing the electrode reactions or cell reactions. So what is the three questions are based here? How galvanic cell or voltaic cell will be constructed? With one example you can show. Second, explain the short notation for the galvanic cell. This one already I had explained. Write the cell reaction and find out the EMF of the cell. That is the third question which is based on galvanic or voltaic cell. Now continue with the further part. We will continue relate only to galvanic cell only. Suppose one more example I will explain over here. Suppose any cell is given. We have to write the cell reactions. We have to find the cell reactions for the given galvanic cell. Which galvanic cell is given? Suppose nickel is given. Nickel in contact with Ni plus 2 ion aqueous having concentration 1 molar. This is 1/2 cell which is written to extreme left hand side. In direct contact by the salt bridge. It is in contact with H plus ion aqueous having 1 molar concentration. H plus ion is obtained from H2 gas having 1 atmospheric pressure. And the electrical contact is done by using the inert metal like platinum. So this one is the second half cell. This is a gas electrode, this is a metal electrode. Now what is the question generally? Write the cell reactions for this one. So how to write the cell reaction? Now as we know that from notation, nickel is placed to left hand side, so it undergoes oxidation half reaction, so it acts as an anode. And all this one acts as a cathode. So reaction at anode. For this one, reaction at anode. Which reaction is at anode? Oxidation half reaction. Oxidation half reaction. Which undergoes oxidation here? Ni. Ni is converted to Ni plus 2 with loss of 2 electrons. Okay. What is second one? H plus ions. So H plus ions gains the electron and it is converted to H. But here it is not given H, here it is H2 is given. So we have to balance it. How to balance it? Make it 2. 2H plus 2 electrons gives H2. See, H plus 2 H2, reduction reaction. If we add this one, this reaction will be at cathode. Reaction at cathode. This is which reaction at cathode? Reduction half reaction. Reduction half reaction. If we add these two reactions, what we will get? 2 electron gets cancelled. Ni plus 2H plus gives Ni plus 2 plus H2. Now what about platinum? Platinum is only for the electrical contact. It can't take place in the reaction part, either reduction or oxidation. It is generally for the electrical contact. So this is the way to find out the cell reactions if any galvanic cell is given. Now continue with the next concept from galvanic cell or voltaic cell. that we will proceed. So concept related to galvanic cell or voltaic cell after writing the cell reaction is the concept of electrode potential. Electrode potential and cell potential. That we will start. The concept of electrode potential and cell potential, that we will start now. Now what is the electrode potential? Just now we know that while drawing the galvanic cell, what we are doing? Two half cells, metal rod is immersed into the solution of its own ion. Suppose this is the metal Mn plus metal M. It is inserted into the solution M plus N. Okay, this is our representation. And these two half cells are connected by a salt bridge. That just how we discussed this part, isn't it? Now what will happen when metal rod is immersed into the solution of its own ion? Then at the separation of this metal, see the surface of separation of metal and the solution, there exists a potential difference. There establish a potential difference. So this potential difference established due to electrode half reactions at the surface of electrode is called as the electrode potential. May I repeat again, what is electrode potential? The potential difference established or occurs at the surface of electrode due to electrode half reaction is called as the electrode reaction. So potential established due to electrode half reaction. Which electrode half reaction? Either oxidation half reaction or reduction half reaction. So if oxidation electrode potential is there and reduction electrode potential is also there. So what is the definition for oxidation electrode potential and reduction electrode potential? It is the potential difference established due to oxidation half reaction at the surface of electrode. It's called as the oxidation electrode potential. Oxidation electrode potential. May I repeat again, what is oxidation electrode potential? It is the potential difference established due to oxidation half reaction at the surface of electrode is called as the oxidation electrode potential. While the potential, which is potential difference established due to reduction half reaction at the surface of its electrode is called as the reduction electrode potential. This electrode potentials at oxidation electrode potential and reduction electrode potential, which are indicated by, see, E means EMF or potential. E of oxidation, electrode potential of oxidation half reaction, which occurs at anode. Okay, and electrode potential E because of reduction, which occurs at cathode. These are the oxidation electrode potential and reduction electrode potential. Now what is cell potential? Cell potential is given by E cell. Electromotive force for cell or cell potential is indicated by E cell. It is the algebraic sum of oxidation electrode potential plus reduction electrode potential. So what is the formula for E cell? E cell is equal to E anode plus E cathode, or E oxidation at anode and E reduction at cathode. But according to IUPAC nomenclature, universally accepted IUPAC nomenclature, generally the E cell or cell potential is considered in terms of the reduction potential values. We are not taking the oxidation potential, electrode potential values. We will consider the reduction potential values. So how to find out then reduction potential values? Here E0 oxidation of anode. If you have to convert this value to reduction part, then make the minus, opposite sign. Minus E reduction occurs at anode. See the change. E oxidation of anode means minus E reduction at anode plus E reduction at cathode. So according to IUPAC concept, we have to measure the cell potential in terms of reduction potential, electrode potential values. So what is the formula for E cell then? Minus E reduction anode plus E reduction cathode. So just we will rearrange little bit. So what we will get? E cathode. No doubt reduction opposite cathode. Now we have minus E anode. And both the values are in reduction potential. So this is the formula to find out EMF of a cell or cell potential is equal to E cathode. Cathode reduction half rate. Cathode E reaction. E cathode minus E anode in terms of the reduction potential values. So this is the formula to find out E cell. Now sometimes this E cell or cell potential is measured at standard conditions. What are the standard conditions? When the concentration of electrolyte, concentration will be 1 molar. When temperature will be 25 degrees Celsius, that is equal to 298 Kelvin. Plus 273 we have to add. So in Kelvin it is 298. When pressure is given in 1 atmosphere. So at STP condition, standard temperature and pressure condition, when cell potential is measured, then it is called as the standard cell potential, E0 cell, indicated by E0 cell. Standard electrode potential is equal to standard reduction potential of cathode minus standard reduction potential of anode. So by using this formula, we are able to find out the standard cell potential. So this is the concept related to galvanic cell, E cell, electrode potential, cell potential, standard electrode potential, standard cell potential. How to find out the E0 cell, that is standard cell potential from E0 cathode minus E0 anode. Is it clear?